Okay, we're on the example question. So what's happening now is we presented the lecture to you. Again, the hope is that you're paying attention, although you may not understand completely what's been presented to you. If you have a broad stroke of what's been presented, that's great. We're talking about polynomials and some things we need to do with those polynomials. So we'll go through examples. Again, it's going to be tough. I know it's a tough section. We'll go through example questions. The example questions will be these questions here. I mean, we're going to work through them. Initially they start off, I'm not going to say too difficult, but they start off and eventually they're going to get more difficult. All right. But we'll go through each one. The intent here is that you probably should pay, really careful attention to what's being presented to you. But at some point after what's being presented to you, you say to yourself, I need time to think about what's been presented. I need time to study. And then I need time to work on problems. All right. So what we do is we give you notes. These notes have structure to it. We also do this at the board. On the side, I also want to point out there's little study spot videos for those students that need to go back and maybe review a little spot video or two. All right. Or for those students that prefer spot videos, whatever works for you. Our goal here is to provide an opportunity for you to move forward in this subject area. All right. So we get through some problems. I realize it's a lot. There's graphs over here. It makes the notes look a lot longer than they actually are. And there's a lot of stuff written down for you. Again, some of the stuff might be confusing to you. We're trying to resolve that confusion by working through it for you, right? But the bottom line is after you work through all that material, you have to get busy. And what are you getting busy doing? Supplemental activities, right? You have to work at this. I mean, it's not like you say, I don't want to work at this. You have to work at this if you want to get through, if you want to be successful. Some activities. I would say this though, a lot of people do this backwards. They do the WebAssign and they say, I'm not going to bother with anything else except for the WebAssign because that's all you're grading. Your intent is to become educated, and that's going to require work. It isn't like going through some, crappy exercise to see if you can get through it by, hunting and pecking around for the answers. You need to study. All right. So we're hoping that you do the supplemental activities. I'll also publish these things. I'm not sure if it's going to be a lecture or just simply a published lecture, and that'll be done towards the end of the week, how much time we have. All right. So what I'm going to do now is I'm going to switch to the whiteboard, and I'm going to work problems. And yeah, it's going to take time and effort. All right. So we're on the whiteboard, and I just want to, let me go back here. And we're going to do one problem at a time. So we're supplemental problems. We're going to do problem number 1. All right. So I'm kind of looking at it. I understand there's a variety of ways of doing it. I'm not saying there's only one way. Now, sometimes there's a variety of ways of doing it. What way do you want me to do it? I want you to do it your way. I really do. Including you look what I'm doing and say, I don't want to do that. But let me write this over here. All right. And let's see, I guess I'm gonna try, sometimes I try things that doesn't work, but I'm gonna try to multiply by its conjugate. Oops, that's not a plus sign, it's a minus sign, isn't it? And that's gonna be 82, 9 minus I. I'm just going back to what I did in Math 100, by the way. I can multiply the bottom of that by its conjugate too. All right, we'll work over here. And what would you go there? If you did the top, you get minus 4i minus I squared. What are you going to bottom minus I squared? We'll finish that up later. Now, I'll be honest with you, I really don't want to do 82 times 9. It just looks like too much work for me. So I'm just going to hold off on that. I'll do it later if I have to. The bottom, though, I need to multiply that out. And 9 times 9 is 81. Then I'd get plus 9i minus 9i minus I squared. I want to keep moving forward. We have an edge key to look at, but right now I'm not worried about that. If I look at the first guy, the bottom is going to be minus a minus 1, which is 1. So what do I get here? Minus 4i, because again, the bottom is just 1. And then minus I squared is minus 1 is plus 1. Oh boy, I got to do this now. 82 times 9 plus I. Now what's nice about the bottom, these things disappear. And what am I left off with? 81 minus a minus 1, which is 82. I wonder about that. I know that they cancel now. And I'm glad I didn't do the multiplication. I saved myself from work. All right, let's keep writing. Oops. This is going to be minus 4i plus 1 minus 9 plus I. So minus 9 minus I. And what do you get over there? Minus 8. And minus 4i minus I is minus 5i. I got in the form of a plus bi. And I'll put this, a is minus 8. This is our goal. And the b is minus 5. Let's go back and check our key, see if we got it right. And if we didn't get it right, we didn't get it right. But we got it right. It's a good deal. I also want to point out an aside over here. I claim that Sage can do complex arithmetic. And you may want to look at that. You might say, you know, I want to try to see if Sage can do that. I just simply typed in the problem. Remember in Sage that I is the unit imaginary number in Sage. All right, remember that. Okay, let's go to next page, number 2. And I'll do number 2. And number 2 says solve the quadratic equation. Well, that's something we've done in Math 100, right? So I guess I could do that. And to do that, I'm going to write that down for you. I don't think I could factor out using my finger numbers, so I can use the quadratic formula. A is 1. You need to know the quadratic formula. B is 2. And C is 9. We'll look at the answer key later. What's x equal to? I'll write down the formula for you. And the formula corresponds to the equation ax squared plus bx plus c equals 0. All right, let's write this down. So it's minus b. And the quadratic formula was derived by completing the square. And you actually did that in Math 100. And I'll go through that again as well. So it's going to be b squared minus 4ac over twice a. So what do you have here? X equals. What's minus b? It's minus 2 plus or minus. B squared is 4 minus, well, let's see, 4 times a, that's 4, times c is 36. Let me just do that again. 4 times 1 is 4, and 4 times 9 is 36. What's twice a? 2. What do you get here? X equals minus 2 plus or minus the square root, 4 minus 36 minus 32. Whoops. I'm sorry about that. And the bottom is 2. Let's keep going. Let's see, minus 2 plus or minus. Well, I'm starting to see the minus 32, so I know there's an I there. And 32 is 16 times 2, so it'll be 4 root 2 over 2. And I think I'm ready for this. What do you get over here? X equals, well, minus 2 divided by 2 is minus 1, plus or minus 4 divided by 2 is 2, so it's 2i root 2. All right, I want to go back to the answer key. I'm going to look at it for you, and I want to see if I got it. And I got it. All right, I'm going to do it a different way, though. And someone says, why do you do them differently? Well, I want to encourage that. I want to encourage people to do things differently. Do it your way. There's another way of doing it. And it's going back to Math 100. Let me write this down for you. X squared plus 2x. Well, what I would do is I would complete the square, subtract 9 from both sides. Well, I want to point out what we're doing. We're completing the square, and something you did in Math 100. Half of that guy would be 1 squared. It's going to be plus 1. So I'm going to add 1 to both sides. And what do you get there? Well, something pretty simple. You get a perfect square, x plus 1 squared equals minus 8. I would then use the square root rule. That would give me x plus 1 equals plus or minus the square root of minus 8. Well, I think I can continue. X equals minus 1 plus or minus. Well, there's certainly an I there. And the square root of 8, I don't know, but it does contain a perfect square of 4. So I'd say 2 root 2. Do we get the same answer? Of course we do, right? So someone's going to say, completing square is a lot easier than the quadratic formula. The quadratic formula is completing a square, but it's a more formalized approach to it. And that's how the formula was derived in Math 100 by completing the square. all right? Both methods lead to the same answer. All right, that was number 2. All right, let's go to number 3. And let me push this stuff over a little bit. So over here it says simplify the complex number. And there's many ways to do it. I don't think for a second that this is the only way to do it, but I want to write it down for you. And it's going to be 9i squared minus 2i cubed. My recommendation is to write everything in terms of things that you know. And there's only 2 things you know, I squared and I. So the first one is 9i squared. I know about that. The second one, I don't know about cubes. So I write it as 2i squared times I. Now what's I squared? It's minus 1. So the first term is just minus 9. What do you give it a second term? Well, I squared again is minus 1. So you get minus 2 times minus 1, which is plus 2. All right. Got that right over here. All right. I'm going to do it a little slightly different way. I'm going to factor it. I'm going to factor I squared out. And what do you get? Well, you'd get, let's see what you'd get. 9 minus 2i. And what's I squared? Minus 1. 9 minus 2i. You'd multiply this out. What do you get? Minus 9 plus 2i. Do we get the same answer? Of course we do. What's the A? Minus 9. What's the B? Is 2. So fairly straightforward questions that you see in Math 100. All right. So let's take a look at this one over here. And this says, again, it might seem unusual to you, but it really has something to do with what we've discussed. It says 3 of the zeros of a real coefficient 4th degree polynomial. So someone says, if it's a 4th degree polynomial, what I'm going to say is that if it's a 4th degree polynomial, there has to be x4 in it somewhere. I may not know what the coefficient is, but there's got to be a 4th degree term in it if it's a 4th degree polynomial. All right, let me erase that. And they say 3 of the zeros. Well, I know that a 4th degree polynomial has 4 zeros, but they say 3 of the zeros of a real coefficient polynomial is a 4th degree are 6, right? And 2 minus 7i. All right, let me read that again. 3 of the zeros of a real coefficient 4th degree polynomial function, right, are 6 and 2 minus 7i. It says, what is the other zero of f? Wow. Let's take a look at that. 3 of the zeros of the real, they only gave me 2. You know what? I'm going to change this question. And I'm going to say there's an error over here. I'm going to change that and write down 3rd degree. I'm sorry about that. That happens sometimes. All right, it happens. All right, so 3 of the zeros of the real coefficient polynomials. Let me change this to 2. All right, so 2 of the zeros of the real coefficient polynomial function. You know what? Maybe they're covered up. Maybe I shouldn't do that. I realize that maybe I just covered it up. I didn't put them all down there. Let me just cover this thing up again. Now I see it. I had it covered up. Unfortunate. Let's write this down then. So again, 4th degree polynomial. I apologize. It happens to me sometimes. There's some coefficient. I don't know what it is. I'll say it's the 4th coefficient, x4, yada, 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 yada. 4th degree. That's all I know about it. All right. What are the roots of it? X equals 7. They gave me 3. X equals 6. And x equals 2 minus 7i. Now, it's a real coefficient polynomial. So what do I know? If it's a real coefficient polynomial, the complex roots have to occur in conjugate pair. So the other root is going to be 2 plus 7i. All right. So if you want to think about it, I'm not saying that was a question. You could do this, x minus 7, x minus 6, x minus, well, a complex root, that would be minus 2 plus 7i. And the next root would be x minus 2 minus a minus a plus 7i. You could multiply that. I don't think they asked for that, though. What do they ask for? What's the other zero? It's this guy. Look at the key, and I'm seeing that. All right, let's go to the next one, number 5. Again, I want to point out for students that find this to go too quickly, this is lecture, and you can always rewatch lectures at the end of the week or watch the embedded videos, and the embedded videos are to each of these questions. All right, this is number 5. And what does it say? Find the zeros algebraically. Let's go through that. So we're looking, when does f of x equal 0? Let's write that down. That's minus 5x5 plus 20x cubed minus 20x. I'm going to claim there's 5 roots. It's a 5th degree polynomial. I'm going to look for them. How do I do that? I'm going to factor it. So let's take a look at that. I'm going to say 5 comes out. I'm going to say minus 5 and an x. And what he left off with? x4 minus 4x squared plus 4. Let's keep going. I'm going to say x squared. Let's see, 2 and 2. All right, got to keep going. Well, I don't know if I want to keep going because I think I can write the roots down now. And I'll point out what I mean by that. I know this guy's root, and I got to figure out these guys over here. Before I do that, though, I want to claim, though, that this can be written this way over here. All right, so I know one of the roots. I know x equals 0. What's the other one going to be? When does x squared minus 2 equal 0? Well, let me see if I can do that. You would get x squared equals 2. X equals plus or minus the root of 2. So I got 2 more roots now. Root 2 and minus root 2. Now remember, I said there was going to be 5 of them. All right, I only got 3. So let's go through this. This one only occurred once, but this guy occurred twice. I hope you realize that. So what would I write down? I could write them down again. Okay, what else they asked me to do? They asked me to graph it. All right, let's go through the graph. I want to make sure you understand they're given that. They said find the zeros algebraically and use your calculator graph. Well, the calculator I'm going to use is my head. All right, so I'm going to write this down for you. And I'm going to graph out f of x equals minus 5x times x squared minus 2 squared. My axes down. And I'm going to list my roots now. What are my roots? Well, one of the roots is 0. That's done. What's the other root? Plus or minus root 2. Then I'm going to do sine analysis. I realize my graph doesn't look that good. Let me go backwards. Because it's got to be symmetric, right? Take a test value after root 2. Now someone says, I don't know what number's after root 2. Well, you should know root 2 is 1 point something. So a good number to choose would be 2. Now what's nice about this? You're plugging it in here. And what would that give you if you plugged in a number after root 2, like 2? It would turn out to be negative. Let me put that down for you. Okay. Now what I want to do is I want to take a number below minus root 2, like minus 2. And if I plugged it in, it would turn out to be positive. All right. Let's keep going. And I want to point out, I want to take a number between 0 and root 2. I'd say 1. And what would that give me? A negative number. Maybe something like this. Now, if I took a number between minus root 2 and 0, like minus 1, and plugged it in, it'd be a positive number. All right. Now, by the way, I don't like the way that looks. I'm going to kind of smooth it out for you. All right. That's my graph. What do I notice about this function? Well, certainly not even. The question is it odd? In other words, is f of x the same as minus f of minus x? Well, I'm going to put that down for you. F of minus x is going to be 5x times x squared minus 2 squared, and minus f of minus x is minus 5x, x squared minus 2 squared. Function's odd. What do I now know? There's symmetry. All right, I know it's got, if looking at it, I want to point out, I'm going to point this out to you. You know, this is easy. This is a relative min. That's a relative max. Over here, I don't know what the point is, but I know it's between those two numbers there. I know that's a relative max. I don't know what that point is, but I know it's here between those two, and it's symmetric with that. It's an odd function. All right, a little simple graph of that. Let's go to the next question. I want to point out these answers are given to you. Let me just go to the answer key. That answer's up there. I guess I didn't do the graph though. Let me see. That was number, wow, we're really sound along, aren't we? Let's go to the next page. And next page we'll do number 6. All right, getting a little better at this now, aren't I? So let's write this down. And let's take a look. I'm going to try to factor it, right? So let's find the zeros algebraically. So really what I'm looking for, when does the function equal 0? And it's going to make it a lot easier for me to graph it. What I'm looking at, I'm going to do factor by grouping. I'm going to say 16, first two terms. What would you get? 3 minus x minus, well, let's take a look at that. That looks kind of crazy looking, doesn't it? I'm going to say, I'm going to factor out a 3 then, right? Minus 3. What would I get? Well, minus 3x squared, isn't it? I'd get, let's see. I can't do that, can I? Sorry about that. I made a mistake. Minus x squared, 3 minus x. Let's check that out. 16 times 3 is 48. 16 times minus x minus 16x. Minus x squared times 3 is minus 3x squared. And minus x squared times minus x plus x cubed. That worked out beautifully. So what do you got over here? 3 minus x, 16 minus x squared. And keep factoring it. This is equal to 0, by the way. 3 minus x, 4 minus x, 4 plus x. Wow, this worked out pretty easy. What are the zeros? Let's list them for you. And these are the x-intercepts, by the way. X equals 3, x equals 4, x equals minus 4. I was expecting, as a cubic, I'm expecting 4 roots. It says graph it. Let's put the graph down. Should be relatively simple. Let's see, 3, 4, and minus 4. Oh boy, the y-intercept would be 48. No, I'm not going to count there. I'll just write that down for you. It's 0, 48. I'm getting that right from the function, by the way. It's super easy. All right, let's connect it up. All right, I'm going to take a number, a test point. I want to point out when I'm testing it for sines. In this thing, it's a factored form of f of x. I'm testing it for sines. What number after 4? I pick 5. What do you get? Negative, negative, positive. It's positive. All right. I'm going to pick a number between 3 and minus 4. And there's already a test point over it. It's over here. I'm going to say maybe something like this over here. I'm not saying it's right, by the way. It's pre-calculus. Now, someone says, why did you take a number between 3 and 4? Well, right now, I guess I should. What's a good number between 3 and 4? I'd say 3.5. What would you get? Well, negative, positive, positive. It's negative. All right. Let's take a number below minus 4, like minus 5. You get positive, positive, negative. What does that give you? Negative. All right. Now, looking at it, I don't see any kind of indication of symmetry. But I do want to point out I'm seeing 3 roots. And I'm seeing, you know, I'm not saying I know what they are, but I'm saying that there's going to be a maximum somewhere. And that's over here somewhere. I don't know where it is, by the way. Don't think it's 0, 40. I'm not saying it's not, but it's I don't think it's there. And over there, there's some kind of minimum over there. All right, so there's 2 relative extremas there. All right, Let's go to number 7. Another, kind of, I would say simple question. And again, what I mean by simple question, it's a 0. So I'll write this over here. F of x is equal to x4 plus 5x squared plus 4. I'm going to try to solve for 0. In other words, set the function equal to 0. And I have to tell you something. This is a real coefficient polynomial. I'm expecting to see 4 solutions to this problem over here. I didn't say I can't, maybe I can't find them, but I'm going to try. I'm going to try to factor. See, 4 and 1 plus plus. Let's see if that works. You get x squared, x4, that's good. 4 and 1's 5, that's good. Yeah, it looks great. So what are my solutions over here? When does x squared equal -1? And the other one, when does x squared equal -4? And what am I saying? I'm looking for the zeros of it. And the only way it could be 0 is x squared is equal to -1, and if x squared is equal to -4. And that's pretty simple. What's x equal? Plus or minus the square root of -1. We'll do that in a second. And this is x equals plus or minus the square root of -4. Do I know the square root of -1? I sure do. And what's that going to be? Plus or minus I. And this is going to be x equals plus or minus 2i. So I found my 4 roots. All right, what do they want me to do? Find the 4 roots. Let's see if they want me to do anything else. Oh, graph it. They said use a calculator to do that. And I got to be honest with you, for a lot of students, without a calculator, this might be tough to do. But you know what? I just want to get a pre-calc sketch. And I hope you agree that all the roots are complex. So I'm not going to be able to graph the roots. They're all complex. What's the y-intercept? It's 4. Sine analysis. Well, you've already got 1 point. This thing's positive everywhere. Now, what do I notice about this? The 4th degree polynomial, I hope you realize that, just looking at that thing, it's going to grow. I mean, certainly going to grow in this direction over here. And this direction, anyway, it's always positive. Looks sort of like this over here. Now, again, I'm not opposed to using a calculator. You can use your calculator. And you may notice that your calculator gives you a better picture than I'm giving you. But here's the deal. We're just looking for a pre-calc sketch. And that's not bad. All right, that was number 7. That wasn't too bad. All right, number 8. Oh, it says something about using a calculator. Now, granted, later on, I'm gonna pull out my Sage. The Sage is written down for you, and I want to emphasize, you're more than welcome to use it. All right, you're more than welcome to do it. But I'm looking at it, and it says use your calculator to find the roots and the relative extrema of that. All right. I got to be honest with you. I don't think I could do that by hand, other than the 5th degree polynomial. I know a 5th degree polynomial, just like leading coefficient test, is going to be going off in that direction when I go towards that in infinity, in this direction over here. What goes on in between that's tough for me. All right, what goes on in between? Now I'm going to say that, looking at it, I'm going to say there would be 5 roots. And I'm going to say, roughly 4 relative extrema. I don't know what they are, though. And I can be honest with you, even like, you study math further, sometimes they're really tough to come up with. And that's why I want to go to a computer algebra system. I'm going to talk through it for you. All right. I'm going to recommend, I'm hoping you're listening to me, that we've done this quite often, but you may not know what the commands are yet. So I'm going to go through the commands for you. All right, this is Sage code. Sage is probably the easiest thing I could do to do the problem in front of you. And you could try this yourself. Open up an instance of Sage. You should know how to do that by now. Reset. What does that do? Play a clean slate of paper. Define x as a variable. Write the function down. What function? This function. Machines are really good at this. Plot f, look at it. I really mean that, look at it. And then what is over here? When you're looking at it, you want to find the roots. And I want to point out, you would know by looking at it that it has roots. You'd see the roots when you look at the picture. And you want to give it a range of roots. And I'm going to say over here is that looking at it, I'm going to say if you did this over here, you would find a root between -1 and 0 by using Sage. And what would it turn out to be? And again, I don't want to be too accurate with this over here, but this is going to return something. And it's going to return x is approximately equal to minus 0.637. Right, approximately. And by the way, if you're looking at your picture, you would know another root is between 0 and 0.5. And if you did this command over here, it would return x is approximately 0.456. If you did this one, again, you have to look at your picture, and you're looking at the numbers between 0.5 and 1, it also has another root between those two numbers. And what is going to be 0.895. So what I'm going to claim over here is that we found 3 approximate real roots. All right. We found 3 approximate real roots. Who did it for us? Sage did it for us. What does that mean? There's 2 complex roots. You're not going to see them in the graph, by the way, because your graphs are the real number system. How will those complex roots appear in? Conjugate pair. All right. I'm also going to point, if you're looking at the graph, I'm going to point out the graph we're talking about, the one you just plotted. You would notice there's a relative min and max. All right. Now, granted, I say, 5 roots, but we only found 3 real roots. And I said 4 relative extrema, we found 2. All right, we found 2. All right. So what do we find over here? The relative maximum occurred when x equals, and again, we're using Sage, and the relative minimum using Sage. And again, you need to look at the picture to do that, was 0.718. Please, if you have trouble with this, come by during office hours, and I'll be more than happy to type those commands in for you. I really mean that. Okay, let's go to the next thing. And again, that's just using your calculator. And by the way, someone says, do I need to use Sage? No, but you need to use technology. And again, I want to warn you this, when you go to other schools, they kind of demand you have to use the software they want you to use. Like, for example, at NJIT, they want you to use MATLAB, right? And they may say, well, you could use Sage, but you still have to submit your work in MATLAB because the graders are only looking at the MATLAB stuff. All right, go to the next page. And let me put number 9 down. And number 9 says find a polynomial of degree 4 that has roots 0, 1, 2, and 3. Well, this is going to be really easy to write down. Because if I know the roots are 0, that means x equals 0. And the other root is x equals 1. And the other root is x equals 2. And the other root is x equals 3. I know it's got these factors then. X minus 0, x minus 1, x minus 2, and x minus 3. I know it has those. So I'm going to say this is the polynomial here. Someone says, is that acceptable? Oh, for the most part it is, but I do want to multiply it out for you. The way I do multiplication may be a little bit different than you, but you should be able to do the multiplication. That's the first 2 factors multiplied together. Second 2 factors would be x squared minus 5x plus 6. I'm going to continue to multiply it together. x4 minus 5x squared, we'll check the answer later, plus 6x, cubed, x squared. And then you get what? Minus x cubed plus 5x squared minus 6x. What do you get there? x4 minus 6x cubed plus 11x squared minus 6x. Let's go to the answer. Go to the answer and see if you got the right answer. X4 minus 6x cubed plus 11x squared minus 6x. This answer is also being listed, by the way, and that's right over here. Okay, let's go to 10. Number 10 says find a polynomial of any degree that has these roots. So how many roots are there? There's 4 roots. Let me write them down for you. One of the roots is x equals minus 7. The other root is x equals 5. And the other root is x equals 1 plus root 3. And the other root is x equals 1 minus root 3. All right? Now, by the way, any degree, you could do a degree 10 million if you want, but I want to do the simplest one possible. So I'm going to say f of x. Well, x minus the first root, that's x plus 7. X minus the second root would be x minus 5. Oh boy, these are going to be tough ones. So x minus that root 1 plus root 3 would be minus 1 minus root 3. And x minus that last root would be minus 1 plus root 3. All right, I find this to be acceptable. Some teachers don't. I want to go through the work. The way I'm going to do that, these two and then these two. Let me go through that with you. That's going to be x squared. Minus 5 plus 7 is plus 2x minus 35. Next one's going to be more difficult. I'll be honest with you. The why it's more difficult is more work. I encourage work. What are you going to get there? I'll write this down for you. It's going to be difficult. X squared minus x plus root 3x. Well, I'm going to multiply by minus 1. So minus x plus 1, right? Let me see if I'm doing this right. Minus x plus 1 minus root 3. All right, a lot of work. Let's keep going. Minus root 3x. Let's see, that's going to be plus root 3. And minus root 3 times plus root 3 is going to be minus 3. So it's a lot of work. Maybe it is. I don't think it's too much, though. X squared minus 2x. Let's see, those root 3x's disappeared. I'm glad about that. And you can get minus 2. Wow, that turned out nice. Let's keep going. Yeah, I know it's work. X4 minus 2x cubed minus 2x squared. Okay, now what? 2x times x squared is going to be plus 2x cubed minus 4x squared minus 4x. We have the key to look at later, don't worry. And let's see, well, minus 35x squared, that's crazy. Oops, sorry about that. Plus 70x. Plus 70. What do you get there? X4, no cubes, minus 35, minus 41, plus 66x, plus 70. Now, by the way, I got to repeat this over again. I make mistakes all the time, but I want to see if I got it right. I'm often shocked sometimes when I don't get something right. I say, how could that have happened? Well, we all make mistakes. X4 minus 41x squared plus 66x plus 70. I also want to point out Sage code is over here for those students that want to try that and see how fast Sage is at it and how slow I was at it. Much slower. All right. All right. Let's take a look at this one over here. And this one says find a polynomial of degree 6, leading coefficient of minus 2. All right, so I know I'm going to have a minus 2x 6 somewhere in the problem. Eventually. I just don't know when I'm going to get there. I don't know this business over here, though. So let me read what they've got. I'm going to erase this over here for you. I'm going to start to read through it. All right. To degree 6 polynomial, leading coefficient of -2, that is given zeros with the indicated multiplicity. So they say root 1. I'll write this down for you. Right? Root 1 that occurs twice. Then it goes on to say root -2, and that occurred only once. And then they say a root of -1, and that occurred 3 times. How many roots do we have? 1, 2, 3, 4, 5, 6. I'm ready to write it down. Well, if the first root is 1 and it occurred twice, it has to have a factor x minus 1 down twice. Then there's a factor that's related to the x minus 2. And again, if x minus 2 equals, 0, I'm sorry, if x minus 2 is a root, that means x plus 2 is a factor. Let's keep going. Last but not least, we got a root of x minus 1, which means x plus 1 is a factor, and it occurred 3 times. All right? I don't mind the answer. I actually prefer it. It's an easier answer for me to write down, but I got to go through the work for you. And I know it's tedious. So what's x minus 1 squared? It's going to be x minus 2x plus 1. And then we get x plus 2. I realize for some students, it's uncontrollably bad for them. They're looking at that algebra and say, they never get through it. A year from now, I couldn't get through it. We're saying, give it a try. So I'm going to say this is going to be x cubed. I'm cubing that x plus 1 term, plus 3x squared. Yeah, I'm doing this in my head, believe it or not. Plus 3x plus 1. That's a lot of work. I know that. Whoops, I made a mistake already. I'm going to do these two. And I'll write it down for you. And what do you get there? X cubed minus 2x squared plus x. Let's see, plus 2x squared minus 4x plus 2. And I'll write this over here, x cubed plus 3x squared plus 3x plus 1. By the way, I'm not the one who needs practice, but you guys definitely need practice at this. But just give me x cubed minus 3x plus 2 times x cubed plus 3x squared plus 3x plus 1. And keep moving through it. And I know it's tough. There's no doubt about it. All right. So what do you get over here? x6 plus 3x5 plus 3x4 plus x cubed. Keep moving. And again, this may take so long you might forget what the question is. And that's why we have a K. We're going to go back. I'm also going to reread the question to you. So I get, minus 3x4 right? Let's see, minus 9x cubed. I get dizzy doing this sometimes too. Minus 9x squared. Let's see, minus 3x plus 2x cubed, right? Plus 6x squared plus 6x plus 2. Wow, this is a lot of work, isn't it? You're going to be thankful for learning Sage at some point in your careers, though. That disappears. Then you get, minus 6x cubed minus 3x squared plus 3x plus 2. But I want to point out, they wanted a leading coefficient of minus 2. So what I got to do, I got to take this thing f of x and multiply it by minus 2. All right, I make mistakes all the time. Let's take a look. think you know what I'm doing, right? And you should do this too. Like I say, I would never thought of doing that. We did a good job. All right. You can be surprised that Sage can do that incredibly quickly. It almost embarrasses me how quick it can do it. All right. That was number 11. Let me go to the next question, which would be number 12. And this is number 12 over here. All right. We'll go through it in stages. I want to point out, looking at it, I have to read it to you. It says, given this function, this is a third degree polynomial. It's going to have three roots. I'm not saying I'm going to be able to find them, but it has three roots. They can be complex. Two relative extrema. It certainly candidates for relative extrema. I'll look for them. But they have questions. And what are the questions going to be? Use the rational root theorem. Now, this is where someone said that. I don't even remember you talking about this. And that's where you need to listen and study that. All right. So A is going to be easy to write down, for me anyway, because I actually listen to myself talk. So I'm going to say plus or minus the factors of 12 divided by the factors of 10. All right, let's write it down. Plus or minus, I know it's tough. What are the factors of 12? 1, 2, 3, 4, not 5, but 6 is, not 7, not 8, not 9, not 10, not 11, but 12 is. What are the factors of 10? 1, 2, not 3, not 4, but 5 is, right? What other number? 10. Now, by the way, as a low bar, I guess you could write that down, but I really want to write them all down. I want to point out what I'm doing over here. I'm going to take these numbers and divide it by these numbers one at a time. Let's do the 1 first. It's an easy division. What do you get? 1, 2, 3, 4, 6, and 12. Now what am I going to do? I'm going to take these numbers and divide it by 2. And what do you get? Well, you get 1/2. Well, what's 2 over 2 is 1. I'm not going to write that down. It's already down. 2/5. And then 2 divided by 10 is 1/5. All right, let's keep going. It's a long list. I'm not saying it's not. We're going to do the 3 now. Well, 3 divided by 1, I'm sorry. We're going to divide by, maybe I should point this out. We did this, we did this. We're doing this now. Sorry about that. I spaced out. We're going to divide through by, let me say I did the right thing. 1, 2, 3, 4, 6, 12. I divided through by 2. You know what? I think I made a mistake somewhere, and I apologize. I spaced out. Let me erase. I really spaced out. And I got to erase this guy too now. Okay. We're divided through by 2. So 1 divided by 2 is 1/2. Oops. Uh, 2 divided by 2 is 1, and 3/2. That's where I made a mistake before. 4 divided by 2 is 2. I wrote it down. 6 divided by 2 is 3. 12 by 2 is 6. I did that one over here. Now we're going to go to 5. And what do you get? 1/5, 2/5, 3/5, 4/5, 6/5. It's a lot of work though, isn't it? And 12/5. Then what are we going to do? We're going to take this last guy, which is 10, and what do you get? You get 1/10. 2/10 is 1/5, right? It's already down. 3/10. I don't have that down. And then what do you get? Let's see, 4/10 is 2/5. I have that down already. 6/10 is 3/5. I have that down already. And 12/10 is 6/5. And I have that down already. So I got them all. Let me count them up for you. It's a lot of counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, plus or minus, there's 32 altogether. All right, let me go back over here. And when I do that, I want to just simply say, I realize this is tedious, and I also think it's unproductive. All right, but I write them all down for you. And let me go through that for you. So let's see, we have plus or minus 1. Let me get it in red. 1, 2, 3, 4, 6, and 12. Right. 1/2. I'm seeing that. 3/2. I'm seeing that. 1/5. I'm seeing that. 2/5. I'm seeing that. 3/5. I'm seeing that. 4/5. I'm seeing that. 6/5. I'm seeing that. 12/5. I'm seeing that. 1/10. I'm seeing that. And 3/10. I'm seeing them all. All right, this is good. And so why do you grade yourself? I'm trying to teach you to grade yourself. You want to, all right? All right, so we did that part. It says test these. God forbid. I really mean that. There's no way I'm going to test those guys, right? I really mean that. I want to find out good candidates to choose from. And I'm going to look at the graph. All right, I'm going to look at the graph. I'm going to look at it. I want to point out I believe there is one candidate that looks better than all other candidates. Someone says, what is that candidate? 2. I'm not going to test all those things out. I'd be here all day doing that. So what do I want to do? I want to test out the candidate. I'll put B down. I want to see if f of 2 is a candidate. It's a candidate. I'm sorry, I want to see if he wins the election. All right. Now, why do I say that? I'm looking at the picture and I'm saying that really does look like 2 to me. I could be wrong, by the way. It looks like 2. It doesn't mean it is 2. So let's write this down. And what's the function? Well, it's going to be 10. 2 cubed is 8. Minus 15. And what's 2 squared is 4, right? Minus 16 times 2 plus 12. Let's see how good we did. 80 minus 60 minus 32 plus 12. Wow, it's a lot of arithmetic, isn't it? Let's keep going. What's this going to give me? 20. That's 80 minus 60. And minus 32 plus 12 is, I'm sorry, is 20. Minus 20. So what do I now know? I know there's a root, and that root is, as expected, is 2. I am going to use that guy to find the other ones. And I'm not saying they're rational, but I want to use it. All right. So let's take a look. I did this. I really didn't do that, but I'll be honest with you, I don't think you should be doing it either. I don't think you should test out every root. That'd just be a waste of time. I tested 2 out. It says use long division now to factor it. Let me point out what I mean by that. So what do I know? I know one of the roots, and I'll write this down for you. I know one of the roots is x equals 2. I know that. I know that f of 2 is 0. So I'm going to use long division. So I'm going to divide through by x minus 2. Now divide what by x minus 2? The function, which is 10x cubed minus 15x squared minus 16x plus 12. All right, let's take a look. So what I'm going to do here is I'm just going to just do it. And I'm going to say 10x squared. That's 10x cubed minus 20x squared. Subtract. And what do you get? 5x squared. Let's keep going. Plus 5x. That will give you 5x squared minus 10x. And what does that give when you subtract? Minus 6x plus 12. What do you get there? Minus 6. Minus 6x plus 12, remainder 0. So now what do I know? I know f of x. I'll write this down for you. Oh boy, made a mistake. I know f of x has a factor of x minus 2 and a factor, let me remind you, 10x squared plus 5x minus 6. I know that. I know it, absolutely know it. What I don't know is what the other roots are. Here comes the problem. Someone could say, could you test out the rational roots on that guy over there? You could, but we got really good techniques for solving a quadratic. I'm going to write them down for you now. All right. So I want to find out when that's equal to 0. Let's write this down over here. So 10x squared plus 5x minus 6 equals 0. Well, I'm not going to use completeness squared because the coefficient in the x squared term is 10, and I don't want to make it a 1. So I use quadratic formula. And yeah, it's work. Let's see, the bottom is, let's see, it's going to be, let's say b squared. I'm sorry, plus or minus b squared minus 4ac twice a. This will be opposite of b over here. Let's see if you can write that down. Let's do the bottom first. That's 20, isn't it? What's the opposite of b? Minus 5. What's b squared? 25. Minus 4. What's a? 10. And what's c? Minus 6. All right, I'm going to keep moving through it. I know it's tough, but I want to move through it. Minus 5 plus or minus. This is 20. I know from math 100 this is a tough part. And what do you get over there? Well, let's see. It's 25 plus something now, right? 240. All right, let's write this down. Well, these are certainly not rational numbers. All right. I just want to briefly go through this with you. Don't be discouraged if you're having trouble. I'm going to divide through by 5. Right? So it's going to be, let me just do it a little differently because I realize some students get very confused by this. Upside down division can be confusing to students. I have to erase that. Well, I didn't know because there's no way to get a perfect square out of that guy. All right, so I got my roots. Let me erase this. I'm going to write them down now. Right? I know it's work. It is work. X equals minus 5 over 20 plus or minus the root 265 over 20. I write it a little differently. Oh, you know what? I'm not going to write it differently. I'll leave it that way. I'll just write down minus 5 over 20 plus root 265 over 20. And the other one is x equals minus 5 over 20 minus root 265 over 20. Let me go back to the questions. I want to make sure you know what you're looking at over here. It says when we did A, we did B, and we did C. That was already done. We did that. And now D is going to factor in. And I realize that really tough. Let's write that down. So I'm going to factor. And we're on letter D now. And so f of x, it's going to be the tough part. I want to write down what f of x is, though. So I can't remember that. It's possible. I mean, a lot of times I can't remember things either. It's 10x cubed minus 15x squared minus 16x plus 12. Now, what do I know about this? I know one of its roots is 2, right? So I can write that down. So I'm going to say x minus 2. By the way, I know 2 other roots. And they're on the side over there. So I'll write this over here. So it's x minus those numbers. So it's going to be plus 5 over 20 minus root 265 over 20 times x plus 5 over 20 plus root 265 over 20. And it's looking crazy looking, isn't it? I got to be honest with you, if you multiply that, you wouldn't be getting 10 on the coefficient there. Hope you can agree with that. All right, I'm hoping you can agree with that. All right, let's play around with it. I'm going to put a 10 here. All right, let's take a look. Let's write this down now. 10, x minus 2. Now, I'll be honest with you, I don't like the 20 there. I'm going to factor it out. So it's going to be 1/20 times 20x plus 5 minus the root 265. Don't be discouraged. Times, I don't like the 20 in that guy either. I'm going to factor it out. And what do you get there? Well, let's take a look. 20x plus 5 plus root 265. Someone says, why is there so much effort put into arithmetic? It's a skill. And the skill you want to acquire that skill. Let's take a look over. That's 1/40. I want to point out what I just looked at, these numbers here. All right, let's keep writing it down. We'll look at the key later. And I'm going to say that's my answer. Let's take a look, see how we did. And again, I'm doing this over here. I want to point out that I have to get the answer because it's a lot of work, right? I mean, I really mean that, a lot of work. And I'm going to pull this. Whoops, sorry about that. Didn't mean to do that. Let's see how we did. It's work though, isn't it? And pretty good, not bad. All right, let's see if we answered all the questions there. And I think we did everything. We really did. We used quadratic formula, we factored it. All right, I'm going to call it quits. We're going to come back and finish up. I know it's exhausting for a lot of students. All right, thank you.